Let's talk a little bit more about kinetic energy specifically. Kinetic energy is pretty easy to understand. So first of all, conceptually, like we already talked about, it's the energy associated with a moving object. How do you calculate that energy quantitatively, though? Well, if you have an energy that's, if you have an object that's just moving around from place to place, which is usually what we mean by motion, we have a very simple formula for kinetic energy, and that formula is going to be that kinetic energy is 1/2 times the object's mass times the object's speed squared. And by the way, you'll notice energy is not a vector, which is good news for you. Energy is just a scalar, just a number. So you don't have to worry about directions here. Let me actually say that a little bit more carefully. So that's the formula for kinetic energy. So some notes about kinetic energy. So first of all, this is not a vector. It has no direction associated with it. A good way to remember that, if you find that confusing, is that you'll notice the v there is squared. It's v squared. So even if you tried to put in a negative velocity into that formula, the square would get rid of your negative sign and would force you to make it positive again. So there's no direction associated with it. And again, that also means it cannot be negative. Mathematically, you can see that right away because mass is always positive and speed is always positive, and also the v is squared. So even if you try to put a negative in there, you'll get a positive answer anyway. So zero kinetic energy means that the object is at rest, assuming it has mass, of course. So that has a very clear meaning. Zero kinetic energy means the object is at rest. Positive kinetic energy means the object is moving. Negative kinetic energy is impossible. It makes no sense. Notice also that because the kinetic energy is not a vector, has no components. It doesn't, sometimes students will try to do like X component of kinetic energy, Y component of kinetic energy. It doesn't have any components. It's not a vector. It doesn't have an angle. It doesn't have a sign. It doesn't have any sort of direction associated with it. Kinetic energy is just a number. And furthermore, it's a positive number, unless it's zero, but it can't be a negative number. Has no components. Kinetic energy has no components. Okay. So I guess those are the main properties of kinetic energy to wrap your head around. It has a very simple formula associated with it. And this is actually a case where students tend to make this more complicated than it is, because you've learned about so many complicated things earlier in the course. You want this to be complicated too. It's not. It's actually extremely simple. All you do, it's just you put in the object's speed, you put in its mass, done. That's it. There's no further complications with it. So it's actually very good news for you. Kinetic energy is very simple.